Hey everyone, welcome back. Today I'm doing something a little different. I'm taking my own DevOps study notes and turning them into a practical, hands-on guide just for you. We're going to tackle a really core Linux skill, mastering process management. You know that feeling, right? An application just hangs, or maybe a script you goes completely haywire, and you're just stuck staring at the screen. Well, knowing how to take back control in those moments, that's not just a neat party trick, it's an absolutely essential skill for anyone who's serious about using Linux. So, here's our game plan for this session. We'll start with the why this even matters. Then, we'll dive into how to actually see what's running. After that, we'll learn the language of signals, which is how you talk to processes. Then, the fun part, getting hands-on with stopping, pausing, and even multitasking. And of course, we'll wrap it all up with a handy cheat sheet. So first things first, why should you even care about this? Well, it's pretty simple. Managing processes is all about system health. It's how you troubleshoot those unresponsive apps, how you free up system resources, and how you keep your whole system stable and running smoothly. It really puts you in the driver's seat. All right, let's pop the hood. Think about it. You can't control what you can't see. So before we do anything else, we have to learn how to look at what's actually happening inside our system. This is diagnostics, and it is the critical first step. Here are the three main tools you're going to use. First up is PS Tree, which I love. It's like a family tree for your processes, showing you which process started which. Then you have PSIFX, which gives you a really detailed snapshot at a single moment in time. But for a live, real-time view, Top is your absolute go-to. It's like an interactive dashboard for your system's health. Okay, so now we can see our processes. The next question is, how do we talk to them? Because, yelling at the screen doesn't really work. We use a very precise language called signals. And understanding this is the absolute core of process control. So, what the heck is a signal? The easiest way to think about it is like a tiny one-word text message that the operating system sends to an application. It doesn't carry a bunch of data. It's just a number that acts as a command, like, hey, shut down now, or just pause for a minute. Now, you don't need to memorize dozens of signals, but you have to know these four. You've got sigterm, number 15, which is the polite request to shut down. Then there's sigkill, number 9, which is the bouncer kicking down the door. It can't be ignored. And my personal favorites, sigstop and sigcont. They are quite literally the pause and play buttons for any process. Okay, enough theory. Let's put these signals into practice. It's time to get our hands dirty and see how to take direct control of a running application. Here's a super simple lab you can try yourself. First, just type sleep 100 and in your terminal. That ampersand at the end tells it to run in the background. The shell will immediately spit back a number. That's its process ID, or PID. Let's say it gives you 1234. Then you just type kill 1234. That's it. By default, that sends the polite sigterm signal we just talked about. And this brings me to the golden rule. Always start with sigterm. It's the polite way. It gives the application a chance to save its work and shut down cleanly. Sigkill is the emergency lever you pull only when that doesn't work. It terminates instantly, which can lead to data corruption. You escalate to sigkill when a process is stuck in a loop and just won't listen to the polite request. Signal number 9, sigkill. This one is special. It's the one signal a process cannot ignore, block, or handle in any way. It's a direct, final command from the operating system kernel. Use it when you absolutely have to, but just understand that you are pulling the plug with zero warning. Now, besides killing by PID, you can also use pkill or killall to target processes by name. This is incredibly useful, but it's also a bit dangerous. If you type, say, pkill Chrome, you aren't just closing one tab. You are shutting down every single Chrome process on your system. So you have to use these with precision and care. Now for something a little less permanent, pausing. Let's say a script is eating up way too much CPU and you need to investigate without killing it. You can send sigstop, which is signal 19, to just pause it in its tracks. Then, once you're ready, you send sigcont, signal 18, and it picks up right where it left off. It's a fantastic way to temporarily free up resources. This brings us to a related concept, shell jobs. Now, it's really important to get the distinction here. We've been talking about processes, which is any program running on your system. A job, on the other hand, is specifically a process that you started from your current terminal session. And mastering this is the real key to multitasking in the command line. And this is your multitasking toolkit. You can start a long task in the background by adding an ampersand at the end. Use the jobs command to see everything you're juggling. Need to interact with one of them? bring it to the foreground with FG. And if you have a stop job you want to restart in the background, that's what BG is for. Whew, we have covered a lot of ground. So let's distill all of this down into a final cheat sheet to summarize the key lessons and the most important commands from our session today. So let's do a quick fire recap. For graceful shutdown, you use kill and the PID. If that doesn't work, kill 9 is your last resort. Deposit process, it's kill 99, and to resume it, kill 99. And if you need to target by name, just remember pkill. This right here is your go-to reference. And finally, these are the golden rules, the absolute must-know best practices. 1. Always be polite, try sigterm before you even think about sigkill. 2. Use pkill and killall very carefully. 3. Jobs only shows you what your current terminal started. And 4, this is a big one. A paused process is not gone. It's still sitting there using up memory. So there you have it. You now have the tools and the knowledge to handle those frozen screens and those runaway scripts. You know how to see, how to communicate with, and how to control the processes on your system. The power is officially in your hands. So the only question is, what will you control first?